Europa's surface delivers 5.4 sieverts of radiation per day, a lethal dose for a human in under 24 hours, and Europa does not even have a sunset to count down to. Brown chemical scars bleeding across cracked ice, ridges splitting open like old wounds. A world that looks like it gave up before it started. But 60 kilometers beneath that dead surface, there is an ocean, roughly 3 billion cubic kilometers of liquid salt water. More than twice the volume of every ocean on Earth, combined on a moon smaller than ours, and that ocean has probably been there for 4 billion years, warm, pressurized, pitch black, completely sealed off from the rest of the solar system. What does water do when it has heat, chemistry, and 4 billion years of total darkness with nobody watching? That question is the reason a $5 billion spacecraft is hurtling toward Jupiter right now. Look at Europa from a distance, and your brain files it under dead. Smaller than Earth's moon, no real atmosphere. Its surface averages minus 160 degrees Celsius. Galileo Galilei spotted it in 1610 through a telescope worse than the one you could buy at a mall. For 4 centuries, Europa was background noise. Just another frozen dot orbiting Jupiter. And honestly, if you saw a photograph of it today with no context, you would scroll past it. It looks like a cracked egg left in a freezer, but the cracks are the tell, not the color, the geometry. Europa is covered in thousands of fractures called linear, some stretching hundreds of kilometers, some wider than highways, carving across the ice in long sweeping curves. Dead moons have cracks too. Old impacts, old stress, frozen in place for billions of years. Europa's cracks are different. Some of them have shifted position between photographs taken years apart. The ice is not sitting still. Something underneath is pushing. Then there are the chaos regions, massive zones where the surface looks like someone shattered a frozen lake the size of a country into blocks, rotated the pieces, and refroze everything. That kind of destruction does not happen on a dead world. It happens when something warm underneath destabilizes the crust from within. And the first real proof came from an old spacecraft that almost missed it. In the late 90s, NASA's Galileo spacecraft flew past Europa 11 times. On one of those passes, it picked up an induced magnetic field. Europa was generating a magnetic signature that changed as it moved through Jupiter's own rotating field. The only known way to produce that kind of fluctuating signal is a global layer of electrically conductive fluid. Not ice, not rock, salt water, liquid, everywhere beneath the surface. So let that land for a second. A moon that looks dead from every angle has a global ocean underneath. And not a small one. Europa's ocean sits somewhere between 60 and 150 kilometers deep. Earth's oceans average about 4. This moon, smaller than ours, holds more liquid water than our entire planet. Earth's oceans are thin films clinging to a rocky surface. Europa's ocean fills the entire gap between the ice shell above and a silicate core below. The ocean is not on the world. The ocean is the world, which raises the obvious question. Europa is nearly 800 million kilometers from the sun. There is not enough solar energy reaching it to warm a cup of coffee. So where is all this heat coming from? The answer is Jupiter, and the mechanism is not gentle. Jupiter is 318 times Earth's mass. Europa orbits inside its gravitational field at only 670,000 kilometers, close enough that Jupiter controls almost every physical process happening on that moon. Europa is tidally locked, one face always pointing at Jupiter. But its orbit is not a perfect circle, it is slightly elliptical. So Europa's distance from Jupiter changes with every revolution. Closer, farther, closer again, every 3.5 days. And that is where it gets violent. When Europa swings closer, Jupiter's gravity pulls harder on the near side than the far side. The entire moon physically stretches. When it moves farther away, the pull weakens and the moon compresses back. Stretch, compress, stretch, compress. Every 3.5 days for 4 billion years. Think of squeezing a rubber ball in your fist over and over for hours. The ball gets warm, not from external heat, from friction inside the material. Europa is that ball. Jupiter is the fist, and the fist has not let go in 4 billion years. That is tidal heating, and it is the only reason Europa has a liquid ocean at all. But here is the part that should bother you. Why is the orbit still elliptical after all this time? Tidal friction should have circularized it billions of years ago. The flexing should have stopped. The ocean should have frozen solid. Europa should be dead. It is not. And the reason is a piece of orbital mechanics so precise it almost looks engineered. Europa is locked in a gravitational pattern with 2 other moons, Io and Ganymede. For every 4 orbits Io completes, Europa finishes exactly 2. Ganymede finishes exactly 1. A 4-to-1 ratio called the Laplace resonance, maintained for billions of years. Every time Europa's orbit starts to circularize, Io and Ganymede pull it back into eccentricity. They are the reason Jupiter's fist never stops squeezing. They are the reason the ocean never froze. 3 moons tugging on each other in a ratio that just happens to keep the middle one warm enough for liquid water, for longer than complex life has existed on Earth. And if you think that is just a neat physics curiosity, look at what it does to Io. The innermost moon in the resonance gets squeezed so hard it has over 400 active volcanoes, the most volcanically active body in the entire solar system. Europa gets less heat than Io, but it gets just the right amount, enough to keep an ocean liquid, not enough to boil it away. A thermal sweet spot sustained by orbital mechanics for 4 billion years. So the ocean is real, the heat source is real, but water and warmth alone do not make a place chemically interesting. You need ingredients, and this is where Europa starts getting annoying in the best possible way. Jupiter's magnetosphere is 20,000 times stronger than Earth's. It traps charged particles, mostly high-energy electrons, and hammers them into Europa's ice at ferocious speeds. That is where the 5.4 sieverts per day comes from. Radiation that would shred DNA in minutes. But that same radiation does something useful. It splits water molecules frozen in the ice. Hydrogen escapes into space. Oxygen stays behind, bonding into hydrogen peroxide and free oxygen locked in the surface ice like chemicals stored on a shelf. So Jupiter is simultaneously sterilizing Europa's surface and stocking it with oxidants, killing everything on top while building a chemical pantry that anything underneath could potentially use as fuel. Now remember those cracks, those chaos regions. Every time the ice recycles, breaks, shifts, and refreezes, it carries those radiation-built oxidants downward, potentially into the ocean. The top delivers chemistry, the bottom delivers heat, and in between, an ocean has been mixing both in total darkness for a stretch of time that is genuinely difficult to get your head around. In 1977, humans discovered hydrothermal vents on Earth's ocean floor for the first time. 2.5 kilometers down, complete blackness, zero sunlight. What they found should not have been there. Giant tube worms, shrimp, entire ecosystems built on bacteria that eat hydrogen sulfide pouring from volcanic cracks in the seafloor. Life running on chemistry instead of light. Chemosynthesis. That single discovery rewrote one of biology's oldest assumptions. Life does not need the sun. Life needs energy. And Europa has energy coming from 2 directions at once. Now, I want to be careful here. Nobody is claiming there is life on Europa. That would require evidence we do not have. But here is what we can say. Europa has liquid salt water, a heat source, a rocky seafloor where water meets mineral, a surface loaded with oxidants being cycled downward, and all of these ingredients together in the dark for roughly 4 billion years. The oldest evidence of life on Earth dates to about 3.8 billion years ago. Some studies push that closer to 4.2. The chemistry on Europa may have been running for just as long. That does not mean life started, but it means the conditions for interesting chemistry have had more uninterrupted time on Europa than complex life has had to evolve on our entire planet. And just when that starts to sound promising, some scientists pulled the rug. In 2026, a team at Washington University in St. Louis published models suggesting Europa's seafloor might be geologically quiet, not necessarily dead, but not the bubbling, vent-covered landscape astrobiologists had been hoping for. The concern is specific. If most of Europa's tidal heat dissipates inside the ice shell rather than the rocky core, the seafloor might not generate active hydrothermal vents. No vents means no chemical gradients at the ocean floor, and without gradients, you lose the most promising energy source for anything resembling biology. That is a genuine problem, and pretending it does not exist would be the opposite of good science. But it also does not close the case. Europa has something no other ocean world in the solar system has. That oxidant cycle from the surface, a top-down energy delivery system powered by Jupiter's radiation. On Earth, life started near heat, at the bottom, in the dark. On Europa, the energy might arrive from above, radiation-forged fuel cycling through ice into water, an inverted chemistry compared to anything we have seen. If that model holds, Europa is not a weaker copy of Earth's deep ocean. It is something entirely different. A world where the chemistry runs in the opposite direction, and we have no template for what that produces. So the ocean is real but unmeasured. The heat is real but debated. The chemistry is plausible but unconfirmed. Every answer opens two new questions. Every model depends on numbers nobody has collected yet. We know the magnetic field signature of a global ocean. We can see the surface cracking and reforming. We know radiation is manufacturing oxidants and the ice is recycling them downward. But we do not know how thick the ice actually is. Estimates range from a few kilometers in some spots to 30 in others. We do not know the ocean's salinity, its pH, its dissolved gas content. We do not know if the seafloor is warm or cold. We are staring at a locked freezer with a warm engine inside, trying to guess what has been cooking for 4 billion years without opening the door. That is exactly what Europa Clipper was built to do. Not to find life, to find out if the conditions for life are even real. Clipper launched in October 2024. Right now, it is coasting through interplanetary space on a 5.5-year flight to Jupiter. It swung past Mars for a gravity assist in March 2025. It will loop back past Earth in December 2026. Then 4 years of silence before it reaches the Jupiter system in April 2030. The reason it will not orbit Europa is the same radiation that makes the surface lethal. Jupiter's magnetosphere would fry the electronics. So instead, Clipper orbits Jupiter and swoops past Europa 49 times. In, data, out. In, data, out. Each pass a few hundred kilometers above the ice. One of its instruments is built to see through the ice. Reason, an ice-penetrating radar, will map what the shell looks like from the inside for the first time. How thick, how layered, whether pockets of liquid water are trapped within the crust. Another instrument is built to taste the air. MassSpex, a mass spectrometer, will sample Europa's faint atmosphere and any plumes of water vapor erupting from the cracks. If the ocean is leaking into space, MassSpex will tell us what is dissolved in it without ever touching the surface. We may not land on Europa in our lifetime. We may not drill through the ice. But Clipper will tell us whether this ocean has what it takes, whether the ingredients are real, or whether we have been projecting hope onto magnetic field data and cracked ice for 30 years. And there is something worth noting about the timeline. Galileo, the spacecraft, detected that induced magnetic field in 1997. Scientists published the data, the world acknowledged it, and then nothing happened for nearly 3 decades. We found evidence of an alien ocean in 1997, and our first dedicated response will not arrive until 2030. That gap says more about how hard it is to reach the places that matter most than any budget number ever could. But Clipper is on its way. $5 billion, 9 instruments, and 49 chances to find out what is actually happening beneath that ice. And even if Clipper confirms everything we hope for, the salt water, the chemistry, the thermal gradients, it still will not answer the question that actually keeps scientists up at night. Because the question is not whether life exists. The question is the time. 4 billion years of water, heat, pressure, and pitch-black isolation. On Earth, that same window turned dead chemistry into tube worms. Europa may have had the same amount of time and produced nothing, or produced something so different from anything on Earth that we would not recognize it if it were floating right in front of us. Either answer rewrites what we think the universe does with the right ingredients when nobody is watching, and that might be the real reason Europa matters. Not because it promises life, because it is the only place we know where the experiment has been running, uninterrupted, longer than we have been capable of wondering about it. 4 billion years of chemistry in total darkness. The universe does not owe us a result, but we have earned the right to open the door and look. Fable, signing out.